Let's solve a differential equation. All right, first order of business. What kind of differential equation is it? Well, it's an ordinary one because we don't see any of these. We look for the highest number of derivatives. There's only one prime here. So this is first order. Is it linear? No, because the y's are squared. Okay, nonlinear narrows it down a lot. It means we're going to have to use some weird little tricks. We could try separation of variables first. Doubt that's going to work, but we'll give it a try. Let's bring this term over here. Xy squared plus 3y squared equals x squared dy dx. And this actually factors. Oh, it is separable. X plus 3 times y squared equals x squared dy over dx. Now, if you multiply by dx, we have x plus 3 dx, divide by y squared and divide by x squared, and that's the new form of it. And now we can integrate both sides. We get negative 1 over y plus c equals, and this is 1 over x and 3 over x squared. 1 over x integrates to natural log absolute value x. 3 over x, negative 1 over negative 1, negative 3 over x. And there's a c. So we could bring these to the other sides and say 1 over y is 3 over x minus natural log absolute value x plus c. And then we flip it over and we get our answer. Y equals 1 over 3 over x minus natural log absolute value x plus c. There's the answer to our differential equation.